So let's have this problem. So to find the integral of trigonometric functions, and these are the different formulas for the integral of trigonometric functions. Then for this given, to evaluate the integral of cosine 5x dx. So from this given, u is equal to 5x and du. So the derivative of u, or the derivative of 5x, that's 5. Then to find the integral, so since the integral of cosine, that's sine u or sine 5x, then over the derivative of u, so over 5 plus c. Then for this given, so u is equal to 2x minus 4. Then du, or the derivative of u, so the derivative of 2x, that's 2. And the derivative of a constant, this one is 0. So du is equal to positive 2. Then to find now the integral, so since the integral of cosecant, that's negative ln, then the absolute value of cosecant u plus cotangent u, then over the derivative of u, then plus c. Then for this given, to find the integral, so we have secant times sine. Since there is no formula to find the integral of secant times sine, so first we need to check if there is an identity. So using this figure, and take note that from this figure, if we multiply the two functions, the result is the middle function. So if we have cotangent times sine, so this is equal to cosine. Then if we have tangent times cosecant, that's equal to secant. So from this given, secant times sine, so this equation is equal to tangent. So we can reduce this given as the integral of tangent 5x plus 2. Then to find out the integral using this equation, so u is equal to 5x plus 2 and du. So the derivative of 5x, that's 5, and the derivative of a constant, this one is 0. So du is equal to 5. Then to find out the integral, so for the integral of tangent, that's negative ln, then the absolute value of cosine u, or cosine 5x plus 2, then over the derivative of u, so over 5, then plus c. And for this given, so to find the integral first, we need to separate this given. So if we have x plus y over 3, so this is equal to x over 3 plus y over 3. So for this given, we can write this one as the integral of 1 over tangent 3x dx, then minus this integral of sine 3x over tangent 3x dx. Then to check if there is an identity using this figure, so take note that the ratio of the two functions, the result, is the function before them. So if we have tangent over secant, the result is the function before them. So if we have cosine over cotangent, so that's equal to sine. Then for cosecant over secant, so that's equal to cotangent. Then if we have tangent over sine, so that's equal to secant. So the result is the function before them. So from this given 1 over tangent, so we have 1 over tangent, so that's equal to cotangent. So this equation is equal to the integral of cotangent 3x dx. Then for the sine over tangent, so sine over tangent, so the function before them, so this is equal to cosine or the integral of cosine 3x dx. Then to evaluate now the integral, so for this term and for this term, so u is equal to 3x and du that's equal to positive 3. Then for the integral of cotangent, so for cotangent, that's positive ln times the absolute value of sine u. So this is ln, then the absolute value of sine 3x over du, so over 3. Then minus for the integral of cosine, and cosine is sine u, so this is sine 3x over 3, then plus c. Then for this given, so to evaluate the integral, so first, we need to expand this given. So if we have x plus 3 to the power 2, so we can write this one as x plus 3 times x plus 3, then apply the FOIL method or use the shortcut method. So the square of the first term, this is x squared. Then you multiply these three numbers. 2 times 3 times x, this is positive 6x. Then plus the square of the second term, that's 9. So therefore, to expand this equation, so the square of 1, that's 1. Then you multiply this 3, so this is 2 tangent 2x. Then plus the square of tangent 2x, so this is tangent squared 2x. So this is how to expand this equation. So we have now the integral of 1 plus 2 tangent 2x plus tangent squared 2x, then the dx. Then this time we need to check if there is an identity. So using this second figure, find the identities. So for this figure, so we just need to focus on a triangle and take note that sine squared plus cosine squared, that's equal to 1. Then if we have tangent squared plus 1, that's equal to secant squared. And 1 plus cotangent squared, that's equal to cosecant squared. So from this equation, so we have this 1 plus tangent squared. So since tangent squared plus 1 is equal to secant squared, so therefore this 1 plus tangent squared is also equal to secant squared. So we can rewrite this as the integral of 2 tangent 2x, then plus this is equal to secant squared 2x times the dx. Then we need to integrate every terms. So put this constant outside. So we have the integral of tangent 2x times the dx. Then plus the integral of secant squared 2x times the dx. Then to find now the integral for every terms. And u is equal to 2x and du that's equal to positive 2. Then to find out the integral, so since the integral of tangent, that's negative ln, but we have this 2, so just bring down 2. So this is negative 2 ln, then the absolute value of cosine u or cosine 2x over du or over 2, then plus for the integral of secant squared, and secant squared is equal to positive tangent 2x, then over 2 plus c. Then we can reduce, so we can cancel these 2. So we have now negative ln cosine 2x plus tangent 2x over 2 plus c. Then for this given, so to find the integral, so first on this case, we need to multiply both sides by the conjugate of this denominator, and the conjugate, since this one is minus, so that is 1 plus sine x, and also the numerator 1 plus sine x. Then to simplify, so if we have 1 minus x times 1 plus x, so this is equal to the square of the first term minus the square of the second term. But since 1 squared is 1, then minus x squared. So in this case, distribute and observe in the denominator, we have 1 minus sine x times 1 plus sine x. So the square of the first term minus the square of the second term. But since 1 squared is just 1, then minus sine squared x. So this is now the denominator. So we have the integral of 1 plus sine x over 1 minus sine squared x, then the dx. Then from this, since we have this 1 minus sine squared, so using this identity, since sine squared plus cosine squared is equal to 1, so we have sine squared plus cosine squared is equal to 1. Then if we transpose this sine squared to the other side, so this becomes cosine squared equals 1 minus sine squared. So therefore, this 1 minus sine squared is equal to cosine squared. So we can write this equation as the integral of 1 plus sine x over cosine squared x times the dx. Then we need to separate now this equation. So the first term is 1 over cosine squared x, then plus sine x over cosine squared x, then the dx. Then apply now the identity. So since 1 over cosine squared, that's equal to secant squared. So this becomes the integral of secant squared x, then the dx. Then for this, we can write this one as sine x over 2 cosine x, or this is equal to 1 over cosine x, then times sine x over cosine x. Since 1 over cosine x, so 1 over cosine x is equal to secant x, then times sine over cosine, so the first function, that's equal to tangent x. So therefore, this equation is equal to secant x times tangent x. Then to find now the integral, so since u is equal to x and du, so the derivative of x is 1. So we have now the integral of secant squared. So secant squared. So since the integral of secant squared is tangent x over 1, because du is equal to 1, then plus the integral of secant x tangent x, so secant u tangent u, that's secant u or secant x, then over 1, then plus c. Or since this is just only 1, so we can eliminate this 1 denominator. So this is equal to tangent x plus secant x plus c.